Let me start the recording. I just started recording, and as a regular practice, I request all the students to drop your roll numbers on the chat box. All of you, please drop your roll numbers on the chat box so as to consolidate that as the today's attendance. So there are 49 students who have joined in today's class. Still 11 more students yet to join. If they join, please ask them to drop their roll numbers onto the attendance. I mean onto the chat box, so as to consider the attendance for today's class. Let me just quickly run through the list of absentees. The list of absentees are 147. After 147, 152, 154, 157, 160, 161, 164, then 167, that's it. Suresh Nitin, what is your number, Suresh? The last participant, what is your number?
167, sir.
Yeah, 167. Okay, drop your number there so as to get the attendance.
Yes, sir.
See, there are some of the students who are repeatedly absent. Okay, anyway. So shall we proceed? From your side, please acknowledge any one of you. Am I audible and is this possible?
Yes, sir. Yes, sir.
Okay, so we have reached to the end of the syllabus actually. So as a part of the last unit, one of the very important and interesting aspect of C++ is exception handling. So in today's class, let us understand what is the definition of exception and how to handle the exceptions in C++. What are the additional keywords that needs to be remembered in order to write the exceptions, and how to code exception handling in C++. Okay. So exception handling is something which is related to errors. Okay. So before we further proceed with the actual programming aspects of exception handlers in C++, let us first understand what are the different types of errors. Okay, so when a coder is writing a program for a specific requirement, if that coder is not following the language rules, then you are not following the syntax, isn't it? So when the coder is using, or when the coder has done some mistakes specifically at the time of coding, then those errors are called as syntax errors. These syntax errors are those errors which can be traced by the compiler itself. So there is no question of bugs here, because the program itself is wrong, because you are not writing the program which is stick to the rules of compiler. Okay. Am I audible? Somebody please come in.
Yes, sir.
Yeah, so let me again re-emphasize. We are discussing the different classification of errors. So the errors are classified into two types. There are two types of errors. One is called as the syntax error. Second is a logical error. Now, syntax errors are those errors which are done by the coders because the coder is not following the compiler specific rules. So these are nothing but your compilation errors. Okay, and your human readable format will not be processed in order to generate its assembly and subsequently the machine code. So therefore, the first category of errors is called as syntax error, which are also called as compilation errors. Now there is a second category of errors which are called as logical error. So what do you mean by logical error? Logical error means the programmer is using the rules of writing the program, such as usage of keywords, and programmer is stick to the rules. So compiler is compiling your program properly, but there are some problems at runtime. Okay, so some of the examples include the division by zero. Okay, so one of the example is division by zero error, right? So here there are logical errors. So here the logical errors, these logical errors, one is it could be like division by zero. I'm actually annotating. Is the annotation is visible to you?
Yes, sir.
So the second example is, assume that you
Sir.
uh, yeah. So assume that you have written an array. Let us say you have declared an array something like int. Okay, so you have declared an array something like int a of 10. So you have an array of a of 10. Okay, so accidentally you have written something like a for loop where you are indexing, let us say, from I is equal to 0 to, let us say, 0 to 20. Okay, so at the time of compilation you will not get any problem, but at the time of accepting the elements or processing the elements, then in the first case you are getting divided by 0 runtime error. Okay, in the second case it is called as array index out of bounds. Okay, so you have declared an array of capacity only 10 records, but you are running a loop in order to maintain total 20 records. So these errors are classified as logical errors. Okay, so these errors are the logical errors, which are nothing but the runtime errors, runtime logic related errors, which will happen only at the execution time. Which will happen only at the execution time. Okay, am I clear? The two classification of errors, syntax errors and logical errors. Is it clear?
Yes, sir.
Yes, sir.
Now, among these two types, we use the notion of exceptions to handle the second classification, that is the logical errors. So what is an exception? Exception is a scenario wherein programmer has written syntax error free based code which is allowing the program to compile without any error, but at runtime, because of some conditions, there is a possibility of logical errors which is resulting a unpredictable output. So this situation is called exception. Okay, so it is a bug. Okay, so sometimes it will also yield to a error. So when will it happen? It will happen only at runtime. Okay, so let me again redefine exception. An exception is a case. It is a specific case. It is a specific case which will happen only at runtime. It will happen only at runtime. Okay, so because of some specific condition, your logic or the program or the implementation that has been converted into logic is resulting some unknown results. Okay, so this is called exception. Is the definition is clear? Is the definition is clear?
So once again, can you repeat?
Yeah, so exception is nothing but a special case. Okay, so it is a special case which will happen only at runtime. What is that special case? It is a special case which will happen only at runtime for already implemented code which is written in C++. Okay, for certain specific inputs, there is a possibility or probability that your program will yield some unexpected outputs. So those are called as exceptions. So one of the example is you are asking the user to enter, let us say, two variables a and b. You are trying to divide a divided by b, and you have not taken a care when b is equal to 0. So when you do a divided by b, when b is equal to 0, you have to handle that as a special case. So this is called exception. So is the definition is clear?
Yes, sir.
Okay. Okay, so this is the last difference between C and C++. So what is the difference? In C, you do not have the provision to handle these exceptions. Whereas in C++, it,
Your audience break.
hello, am I audible? Am I audible?
Yes, sir.
Yes, sir.
Somebody was responding. Yeah. So let me again repeat. An exception is a special case which will happen only at the runtime. For already implemented C++ code, there exists a special condition. Okay, so under certain specific input, there is a possibility that your program will result into abrupt termination or unpredictable outputs. So those situations are called as exceptions. Now these exceptions are caused because of illegal instruction executions such as division by zero or array index out of bounds or some other various other types of exceptions are also there. Okay. Are you following?
Yes, sir.
Yes, sir.
Okay. So coming to the emphasis between a implemented code in C versus an implemented code in C++. Okay, so this is the last difference that we will understand in this course. Okay, so where in C it is not possible to write the special code to address these exceptions, whereas in C++ exceptions can be written, can be handled at a specific place, and the statements that are specifically written in order to handle these situations are called as exception handlers. Okay, so this is the last difference between C and C++. In C, exception handling is not supported, whereas in C++, exception handlers are supported. Now notice that exceptions are nothing but bugs. Okay, and those are the bugs which your program is prone to any unnecessary inputs. Okay, even if user enters those inputs, you should fix those bugs as a special code, treating it as an exception. Clear? Shall I proceed?
Sir.
Yes, sir.
Okay. So in C++, we use the exception handlers and we write the special code by using the three keywords. So what are the three keywords? One is the try block. Somebody is allowing me allowed to annotate. No. Okay, so me keep this here. Yeah. So the first keyword is try. Okay, so second keyword is throw, and the third keyword is catch. Okay, so what is the procedure to handle the exceptions? Okay, so in a program which is a sequentially executed program, you identify the set of lines where there is a possibility of exceptions. So assume that in these lines there is a possibility of exceptions. Okay, so these lines you write a try block. Okay, so you keep a opening brace, you keep a closing brace, and then what you are saying in C++ is within this vicinity there is a possibility that I may get an exception. Okay, so something similar to division by 0. When I accept C in A and then C in B, now before I do C is equal to A by B, there is a possibility that B could be 0. Okay, so before I proceed to divide, I need to cross confirm that B is not 0. So step 1 is identify the exception possible C++ code, and all those statements keep under a try block. This is step 1. Okay, then step 2 is identify the condition for which you will get an exception. Identify the condition for which you will get an exception, and then you use the keyword throw with a specific data type. You use the keyword throw to throw the exception with a specific data type. We will soon see one example. This is step 2. What is step 1? Identify the code. Step 2, identify the specific case. Then in step 2 only you have to throw the exception. So once you throw, then the control will go to catch. The control will come to catch. Now please make sure that every try block, wherever you are saying that there is a possibility of exceptions, must be started with at least one catch block. Every try block must be started with at least one catch block. It is also possible to write multiple catches under one try. We will see that also. So let me again repeat the 3 rules. The 3 rules of handling the exceptions are: first, identify the source lines in your program, or code lines in your lines of the code in your program which are prone to exceptions. You keep that block under the try with opening brace and closing brace. Now within that scope, since you have identified that there is a possibility of exceptions, you identify in the next step, which is step 2, you identify the condition for exception. So once you get that condition as true, then you use the keyword throw, you throw the exception. So this is step 2. Am I audible? Can somebody respond?
Sir.
Yes, sir.
Yeah, so once you throw it, then even though you have multiple lines of other statements under throw, all other statements will be skipped and it will directly go to the exception handler. Now the place where you are writing the code in catch block, this is called as exception handler. This is called as exception handler. Now notice that the catch block looks like a function call. However, it is not a function call. It is a exception handler. Okay, so what it does is it takes the control, and then here you can write the corrective code that you want to execute. The corrective code that you want to execute. Now after executing this catch block, it will not again go back to throw where you are throwing. It will not go back. It will continue executing the other part of the code. Okay. So as is shown in the right side of your slide, there is a try block. There is a try block here. which is possible. Where in some lines there is a possibility of exception. When you get an exception, you check the condition when you get an exception. So once you get an exception, you can throw that exception. Now, while you are throwing, you can throw multiple data types. Okay, so therefore, under one try block, it is possible to have any number of catches. To which catch it has to go is based on what are you throwing. What are you throwing? If it is an integer, it goes to integer catch. If you are throwing a string, then it goes to a string catch. If you are throwing a character, then it will go to a character catch. Okay. So this is about the syntax. First understand the syntax. Now I'll take up the same example of division by zero exception, and we will start understanding how the exception handling can be coded in C++. And subsequently, we will look into the other programming aspects of handling the exceptions. Any doubts? Anybody has any doubts?
Sir.
Yeah, go ahead.
Sir, we'll use many loops, no, sir,
We use?
for if loop, no, sir, for handling bugs. If
No,
b not equal to 0.
1 minute. If is not a loop. If is a conditional statement.
Sir, conditional statement.
Hmm.
We'll try to, if b not equal to 0, then we'll take their, no, sir.
No. The point is, the point is, if b is equal to 0, that means you have to handle that as an exception. So if b is equal to 0, you can throw. So what has to be thrown is again up to you. You can throw an integer. Let us say you are throwing probably 1. Then assume that in this catch you are handling the integer. We will see that. We will see the example. Then you will understand. You will understand how the exceptions can be handled. Before that, try to understand the syntax. So in order to handle the exceptions, the 3 keywords which are used in C++ are try, throw, and catch. You cannot start writing an exception handler first and then trying next. First, try has to be there. Immediately after try, catch has to be there. And throw is a part of try block. Throw is a part of try block. So remember this as a part of syntax for writing the exception handling in C++. Clear?
Sir,
Yeah.
sir, if we throw one, if we throw once, it will won't come again to try na, sir, again.
No, it will not again come. For example, you have thrown 1 here, then from here it goes to this catch block. Whatever you want to do, you do here. And then whatever other code that you have written after all catches, it will start after executing this exception handler, it will jump to here.
Then how 2 throws can be in one try?
How 2
Two throw blocks can be
yeah,
in one.
how 2 throw blocks can be in one. I'll tell you an example. For example, I want to divide the number, and if my second number is 0, I want to say that it is not possible to the user. So I will handle that as throw 1, and then I'll indicate here, and then I'll simply come out. On the other hand, if the second number is, let us say, negative, then I'll I'll use the second throw. So in the second throw, what I'll do is I'll send a message saying that a message is nothing but your cat star, isn't it? So I'll send a message, and then in the second catch, or probably in the catch in this example, sorry. So in this example, this throw is here. That means I'm assuming that this catch is going to handle the string. So I'm passing this string. Okay, and here what I'm doing is, even though user is entering the negative number, I'm going to ignore negative sign. Then I'll be writing the logic for C is equal to A by B. It is only the corrective measure. So what is the point here? even though there is only one try block, if user is entering 0, I'm not at all dividing. And if user enters a negative number where as per the requirements he should not enter, but even if he enters, then I'm writing a corrective logic in my catch, which is a third catch, where I'm considering only the positive sign and then I'm continuing. But in that process, I'll also tell that, see what inputs you have given is not correct, but still I have done it. Understood? So it is possible
Yes, sir.
to throw multiple things. Only thing is what are you throwing? The throwing data types must vary, which is same as something like function overloading. So one of the important point to remember here is catch is not a function. Please note, catch is not a function. It is the instance that you are creating. It is the address that is being pointed at the program memory, which is binded to a specific throw type. So when you get a specific throw type, a specific catch block will start executing. So only thing is when the program flow comes to a throw, then it will identify whether you have a catch of that type. If there is a match, then it directly routes the program flow from the other part of the try block to that particular catch block. And once that catch block code is completed, then it skips all other catches and it goes outside of the catch. Clear?
Sir, if number is negative and 1 was 0, means B was 0 and A was negative, then we have to change A as well as the 0, no, sir.
No, see, that's what I'm saying again. Here, there are two possibilities. Sorry, now you have given an example where you got two exceptions. So among these two, which is more important for you needs to be handled first. Okay, so if you write catch int first, then the integer catch will be handled and your second case will be ignored because the number can't be negative. You have entered a negative number. We will see that. Okay. I'll show the same example in the online editor. So first thing is, the basics are clear. What is an exception? It is at runtime. At places where we have code, there is a possibility that can enter anything and that anything can cause some serious damage to the output. So that can be handled in the special code that is called as a exception handler. So your exception handler, where will you write? In the catch block. Any other doubts? Anybody has any other doubts?
So,
Hmm.
sir, what happens to the code block in between try and catch?
What happens to the code block in between try and catch? See, the point is you are asking the user to enter the inputs. Maybe I'll change the color. Okay, you are asking the user to enter the inputs. Okay, so the inputs are given. Assume that these inputs are okay. I mean, these inputs are fine. So that means the condition for which you are thinking of an exception is not happening. It is not happening. That means you are not throwing. So it executes the other part of the code. And the condition which will be enabling to throw this is also not happening. So this is also not happening. Then whatever inputs the user has entered, they are the logical inputs. That means you have to execute the program as usual. Simple. So what happens to the code if code in between try and catch, if you are not throwing, then it is a regular sequential execution of code. Okay, so at the end of try block, once your program has not entered into any of the throw blocks, then it will never enter into any of these catch blocks because there is no need. So after this, it directly goes here. That is the rest of the other program. Clear?
Yes, sir.
Okay. Now let us take up an example. Any other doubts? So notice that this is very simple concept, very small examples we will take, but the inferences are very important, and this has been asked many times, mainly as long answer questions. Every year, every end exam, you will get a short note on exception handling, or what are the different points that needs to be remembered when you are dealing with exception handling in C++. Okay, so I have some 8 to 9 examples. Let us concentrate one by one, and we will understand the programming aspects now. So let us take the first example of dividing the two numbers. So I have already given the pseudocode on this slide, which is visible on your screens now. As you can see, there are three variables, A, B, C. So you are asking the user to enter the values of A and B. So that is nothing but a cout statement, and then you are reading the inputs, which are nothing but cin. Now this is a crucial block. What is crucial? You have to make a computation of C is equal to A by B. So this is where there is a likelihood or there is a probability of getting an exception. Now I am considering if B is equal to 0, that means I have to keep this code, which is C is equal to A by B, under try block. Okay, so this is step 1. You need to identify the statements that needs to be kept under try block. So I have identified that C is equal to A by B is crucial, and I am keeping this C is equal to A by B under try block. Now what is the condition of exception? If B is equal to 0, I am saying that you throw an exception saying that you are attempting to divide it by 0. So what is the data type that I am throwing here? This is a string. Yes or no? So I am throwing a string. So once the user by mistake or intentionally has entered the value of B as 0, then it will not execute C is equal to A by B. What it does, it throws and it searches a catch block that has the throw data type. What is the throw data type? It is char star. So it matches the catch here, and then it will start executing here. So what is this code? This code here is an exception handler. We are not writing any corrective action here. Instead, we are displaying a message. Now notice that there is another object which is CERR. This CERR is a specifically used object which is created in the catch block to throw the error logs which are generated because of exceptions. Let me again repeat. CERR is same as cout, but this is specifically created object in exception class. There is an exception class which is used in order to throw the error logs, to generate the error reports, as the exception handling process. Very important point to be noticed here is this is not a function called gem. This is a control gem, flow control gem, execution flow control gem. After completing this exception handling, when user is entering 0, notice that there is no going back. You're not going back again to here. You are continuing the other part of the code, which is something like your switch case, something like your switch case. Understood? Let us start coding it. If you have any doubts, maybe you can come in and let me stop annotating. Yeah. Any doubts? I'm handling here the only one exception when B is equal to 0. Subsequently, we will add the other exceptions. Please come in. Are you following? Any doubts?
No, sir.
I'm not getting any response. Are you following?
Yes, sir.
Yeah,
Yes,
I think
sir.
174 has raised a hand. You have any doubts? 174. Let me check the chat box. If students are using chat box. Anybody probably can read out the doubts if anybody has asked. 146. Are bugs, exceptions, errors are same? Most often, yes. Errors are not same. Errors and exceptions, they are different. Consider a division of two numbers as an example. Yeah, fine. We are doing that. Consider the division of two numbers as an example. Okay. Any other doubts? Any other doubts?
Sir, need to study exception. Justification to study exceptions.
Yeah, that is a good question. You will understand once you are once we read. Once we reach the other parts of the code by using which you can handle the exception.
Sir, I was saying that we can also write if b is double equal to 0, C out, division not possible, else we can do return C equal to A by B, no, sir. Like that also we can do, no, sir. Why are we studying?
Yeah, that is correct. That is a correct reasoning. I will readdress this with a specific emphasis once we complete the other examples. You will understand. Hang on for a little time. Okay, so as of now, understand that there is a special method where you can jump, where you can ask your program to jump to a specific address, and then it is possible to do corrective measures. That is the point here. And then it is possible to do corrective measures. Okay, so why are we studying? I'll just repeat one more point here because you have raised that important point. You can probably write if double equal to 0 and then you can terminate the application. That is what you are saying, isn't it?
Yes, sir.
But if I use exception, what I can do is I can do the corrective action here. Okay, I can do, I'm not worrying about a simple example like this where I will change probably b is equal to 1. I'll change probably b is equal to 1 and assume that this is a function, and again I'll call the same function. So then I'm fixing my exception. Yes or no? Then I'm fixing my exception. Even though user is entering b is equal to 0, I'm reiterating the same process. You will understand later. As of now, ignore it. Okay? Shall I proceed?
Sir.
Shall I
Yes, sir.
proceed? Yeah, fine. So let me switch to the compiler. Oh, still it is, annotation is on. Okay, I need to click that. Let us start our first program of handling the exception. Int main. Okay, so I need three variables a, b, and then c. Now I'll say c out to enter a comma b. Now c in, take that into a and take the other variable into b. Now try block. In try block, if b is double equal to 0, then this is where I throw a string divide by 0 exception. So I'm throwing a string. We are throwing a string. Okay. If b is not 0, then I'll be coming here. So at that time only I'm making ensure that my division is happening, which is c is equal to a by b. And then I'll print c out. Let us say the value of c is equal to sc. Okay. Now notice that you need to have at least one catch block. Catch. You are getting constant char star message. Okay, so whatever message you are getting, which is we will be handling by using CERR. Let us simply print that same message, then NDL. And then we will write that C out, just a message. Then this is a main which is returning integers, so return 1. Okay, clear? This is a simple program of handling division by zero exception, where I have taken care to enter any number. If user enters intentionally or by some chance 0, I'm handling that as a exception by writing try, throw, catch block. So shall I compile? Shall I compile?
Yes, sir.
Now it is asking you enter two numbers A and B. Let me enter 12 and then 5. So now there is no possibility of exception because you will get the answer as 2. So answer is 2, and then there is no try, throw, catch. Nothing is coming. You're following? So whatever code is there in between try, catch, throw is getting ignored. C is equal to A by B got executed because it is a legal value. Then you are getting the value of C as 2. On the other hand, if user enters, let us say 12 and then 0, since it is 0, then the point is you are not terminating the program at line number 12. You are taking the control back again to catch block. Now this is called as exception handler. This is called as exception handler. Once you reach the catch block, then it is possible inside the catch block whatever you want to do. So as of now, we are not doing anything. We are simply displaying the message that has been generated because of try, throw block, and we are printing that to divide by 0. Clear? So is the example is clear? Anybody
Yes, sir.
any doubts? Anybody has any doubts? Am I audible?
No, sir.
No, sir.
Sir.
Yes, sir.
Okay. Now assume that I want two exceptions to handle in this case. First exception is if B is 0, then I want you to display the message saying that division you are doing, there is an attempt to divide by 0, which is there here. I mean, which we have already done now. Another thing is if B is negative, then I should say that no, I don't want to divide if A is negative or B is negative. Okay, so let me again reiterate my requirement. My requirement is if A or B are two numbers such that they are greater than 0, then only you have to divide. Okay, so if B is equal to 0, then what you have to do is you display that you are trying to divide it by 0. Whereas if B or A, if A or B, if they are less than 0, okay, so then what you do is you ignore the sign, bit, and then you divide A divided by B. A and B can't be negative. If user intentionally is entering or somehow unknowingly if user is entering any negative numbers, then even if the user enters the negative numbers, then you print only A divided by B. My point here is I want to differentiate two exception handlers. Here I need to display a message here, other than displaying a message, I need some extra code. How is it possible to do? It is possible to do by writing multiple catch blocks, under single try. Okay, so here you are throwing a string. So this is a string that you have thrown when b is equal to 0. So therefore it is reaching this catch block. On the other hand, if a is less than 0 or if b is also less than 0, if either of this is 0, okay, so then you will need to go to some catch. Okay, so you need to go to some other catch. Clear? So let us continue this. Shall I mean, are you following what happened?
Yes, sir.
Okay, fine.
Sir, what happens if we write C out instead of C here?
Nothing happens. Only thing is, C error is another object. If you want, you use. If you don't want, don't use. It's a log. It's a logged object. Logging. This is called error logging. Okay. What happened? Annotation.
Sir.
Okay. Maybe I'll copy this, and then because I'm going to change the code, I'm putting that as program 1. Just saving it. Now I'm turning back to the same GDB compiler. Notice that you are asking A and B, and then you are trying B is equal to 0, you are throwing this. Now I'll write another throw, that is if A is less than 0 or if B is less than 0, then I will throw other data type. Probably I'll throw 1. Okay, now what is that you are throwing here? You are throwing an integer. What is that you are throwing earlier? It was a string. Okay, so after this, if b is not 0 and if a and b are positive numbers, then you will be continuing with c is equal to a by b and you will be printing c. Clear? On the other hand, if b is 0, then the control will move from line number 12 to line number 18. On the other hand, if a is negative or b is negative, then the control will reach till line number 14, and from line number 14 it jumps to line number 22 now. So now what I'm going to do in line number 22 is I'm going to write another catch int, let us say exception E. Okay, so here what I'm doing is I'll again write CERR. Here either A or B are negative. Okay, so now what I'll do is I'll check whether I'll check if A is negative or B is negative. If A is less than 0, then I'll say that A is equal to minus A. Okay, else B is equal to minus B. And then I will continue doing C is equal to A by B. Then again I'll print C out. Here, so line number 22 to line number 31 is a exception handler where you have taken care for those inputs where your inputs could be negative. Okay, that is A or B. Here, shall I compile? Please,
Yes, sir.
yeah. So let us start running it. So now let me enter 12 and then 5. Got 2. Let me again run this, and then I'll enter the second argument as 0. Now I got the first exception handler execution. Let me again run. Now I'll enter the first argument as 12. Argument as 12. Already has taken 12. Okay. Let me again re-execute this. So I'll enter probably 35 and then minus 7, minus 8. I have to get 4. Either A or B are negative, and then I have handled that in the second exception handler. And then we have displayed C is equal to 4. Here calculation is not important. You understand the logic, how it has to be written. Point is it possible to write multiple catches under a try? The answer is yes. The another point is, why is it required? It is required to differentiate multiple events. What are the events in this example? Getting B is equal to 0 is one event. Getting A as negative number is another event. Getting B as negative number is also another event. So we are in a position to differentiate and take a control of the program to the specific address. Instead of continuing with the regular sequential flow, you are in a position to route that program flow to a specific address for specific inputs, which are exception based in conditions. Clear? Clear?
Yes, sir.
Okay.
Sir, if A and B both are negative, the resultant answer will be also negative, no, sir?
Negative, yeah, I think that exception I have not handled here. I said A and okay, fine. So let me write that exception also. So if A is less than 0 or B is less than 0, you are doing it. So before handling this, if both are 0, I'll handle. I mean, if both are negative, A is less than 0 and
Sir, just remove.
come again,
Just remove else and keep if na, sir.
remove else. Where?
And keep if in catch.
I'm not getting. Come again in catch.
In catch, remove else and keep if at that place.
Else if and
0.
and keep 0.
Okay, but if both are less than 0, then
Wait, sir. Then the negative will be cancelled.
we'll get again negative. No? If both are less than 0. Okay,
Sir,
so therefore,
if we replace if with else with if, we
hmm,
can handle both in one case now, sir.
that's what I'm again checking. If A is, let us say, minus 4, B is also, let us say, minus 2, what will be minus 4 divided by minus 2? Is it 2 or is it minus 2? No, you tell me mathematically. Minus 4 divided by minus 2 is how much? Is it 2
2.
minus 2?
2.
It has to be 2.
2, sir.
Plus 2,
Yes, sir.
Plus 2, sir.
Plus
Plus
2.
2.
Plus 2 only. Okay, so if A is less than 0, you are, let us assume you are changing, and B uh, if B is also less than 0, then you are changing B. Yeah, I think that is okay. You can keep if B is less than 0, then this case is not required. Okay. So let me compile and then take minus 4 and then minus 2. Okay. Is that clear?
Yes, sir.
Yes, sir.
Okay, so another case is, I think this we have already handled. If b is less than 0, notice that you are throwing an integer. If b is equal to 0, notice that in this slide he is throwing a character. Okay, so notice that the place where you are keeping catch is immaterial. That means if integer catch is next and then character catch is first, when you throw ASCII 0, it enters into the character catch only. Whereas if you are throwing an integer, it enters into integer catch only. Okay. Are you following? You have any doubt?
Yes, sir.
Sir, can we write catch about try?
Can I didn't get you. Can you write?
Catch about try, sir.
Just హలో సార్ సార్ నేను ఇంకా క్లాస్లో ఉన్నాను సార్ ఒక 20 minutes తర్వాత నేను కాల్ చేస్తాను సార్ ఏం సార్ దేని గురించి అది థీమ్ బేస్డ్ ప్రాజెక్ట్సా సార్ ఓకే 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 సార్ నేను ఒక 20 minutesలో కాల్ చేస్తాను సార్ క్లాస్లో మధ్యలో యా గో హెడ్ ఐ థింక్ సంబడి ఈస్ సేయింగ్ సంథింగ్ యూ వాంట్ మీ టు రైట్ ఏ క్యాచ్
About try. We can write.
I'm not getting. Come again.
No, sir. First we are writing try, then catch. No, sir.
Okay. First we have written try and then catch. Yes.
Can we write catch then try, sir?
No. Not correct. First you have to try and then you have to catch. It's something like you are. It is something like a bowler is bowling and even the batsman is not hitting the ball. You are taking a catch. How is it possible? Not possible. Okay, so you cannot write catch before try. Okay. Any other doubts? Any other doubts? Any other doubts?
Sir, didn't
sir.
executed the case.
Come again.
Didn't executed the case, sir. One is negative and another is 0.
Okay, we want me to execute. One is negative, another is positive, right?
0 and another is negative.
Oh, okay. First is negative. Let us take -6 and b is 0. So out of these two, now as a coder, which exception you have given? Which exception you are handling first? The line number 11 will be handled first. So you will get a message saying that divide by 0. You will not be again getting -6 as to be treated as 6. So if I enter this, then you will get divide by 0 exception. That means only one exception can be handled at a time. You cannot cascade multiple exceptions. Clear?
Yes, sir.
Any other doubt? Now here I have a specific doubt. See here, this fellow is entering an integer, this fellow is entering a character. What if I enter a string here and I have not written a catch? Then it simply ignores. Let me repeat. You have written throw 1. You have also written throw 0, which is ASCII 0. And you have integer catch, you have a ASCII catch. But you don't have a string catch. So let us assume if b is less than 0, I am throwing it is a negative number and there is no catch. Then what happens? Then what happens is, as usual, it will come out and it will try to find is there any catch. Once there is no catch, okay, your program will be terminated abruptly because you have not handled the specific exception. Did you understood what I am saying?
Sir.
Understood?
Yes, sir.
In this example, what we have demonstrated, what we will do is, I am deliberately writing if b is double equal to 5, I will throw, let us say, a ASCII character, say a ASCII character error E. Now the point is, do I have a ASCII catch here? No. There is no ASCII catch. Now let us understand what will happen. If I enter b is equal to 5, means you are expecting the user not to enter 5. But if I enter, let us say 14, then b as 5, then program will be terminated abruptly. Why? Because you are throwing a character catch, but it is terminated called after throwing an instance of character, and your program is terminated because you have treated the exception, but you have not handled it. Clear? Clear? Am I clear?
Yes, sir.
Okay. Now let us move to the third one. So in order to handle such catches, there is something called as a universal exception handler. Okay. So if you write catch within brackets triple dot, then this can catch any exception. This can catch any exception. Okay. So let me again go back to the problem here. Now what I'll do is, the end here, I will write catch dot dot dot. Now what is this? This is a universal exception handler. Okay, so when this will be used, whenever I am throwing anything, and that throw based exception handler, if I have not defined anywhere, then I'll say that I got an exception. Okay, so let me again re-execute the same program with the specifically b is equal to 5. Okay, so in that case, you will get the universal exception handler. Let us compile this. Let us enter 18 and then 7. No, not 7. What is it? 5. Then I'm getting a universal exception. That is, I got an exception. Here, this is many times asked 2 marks question. What is catch dot dot dot? It is a universal catcher, or it is called as a universal exception handler, which can accept any throw, any data type of anything. Are you following? Are you following?
Yes, sir.
Also notice that if I keep this universal catcher just before or just after the try block, if I enter the second number as 0, then what will be my output? Will I get divide by 0 exception, or will I get I got an exception?
Divide by 0.
Again?
Divide by 0.
Okay, let us test it. You will get divide by 0 only. Yeah, I forgot to tell, this is syntax error. Your universal catcher syntactically must be at the end. So this is universal exception handler. This handler must be at the last handler, if at all you are writing. You can't keep the universal handler at the front, neither in between. Example, I want to write here. No, not here. I want to write here. Now also it is not possible. Okay, so your exception, you handle the exceptions for those exceptions for which you are waiting, and if at all you want to handle any other exceptions, safe part is you write catch triple dot, which is a universal exception handler, and then you handle the exception. Clear? Let me execute this. Let us take A and B, and then let us take 13, and then maybe how much is that? -7, right? If I enter -7, I will not get universal exception. What I'll get is I get either A or B, specific exception. For those exception handlers, for those throws whose data types based catches are not there, only then your catch block will be treated as a universal exception handler, and the code within the catch triple dot will be getting executed. Am I clear? Am I clear?
Yes, sir.
In this example, which is there on the slide, notice that I don't have any other catches. If you are throwing one, if you are throwing a ASCII 0, or if you are throwing a string, everything will be handled by this catch. Okay. Next, notice that there is no notice that there is no implicit typecasting. That means what? If you are throwing 1, it is an integer throw. If you are throwing 0, it is ASCII 0, but it will automatically, it will not implicitly convert to integer. Okay. That means if you are throwing 0, this will not go to this catch. This will not go to this catch. Instead, this will go to a universal catcher. This is an important point. So implicit type conversion doesn't happen for primitive types. Is the point is clear? Is the point is clear?
Yes, sir.
When you are
Yes, sir.
1 will be handled as an integer catcher, but when you are throwing 0, ASCII 0, since there is no ASCII catcher, it goes to universal catcher. Okay. Shall I proceed?
Sir, can we come back to main again?
No, you cannot come back. Once you enter into catch, main only. Catch is also inside main. Catch is also inside main. Now,
I mean the place where we jump.
no, you cannot come. You cannot go back. Once you enter into catch, for example, because of 1 you entered here. Okay, so then you are entering, you are executing this, and after the end of this, you are jumping here. You cannot go back again from here to here. You cannot go back unless and until you make a function call or you make a go-to statement. But that is a bad programming. When you get an exception, you have to come out. But there is another case. Another case is if is it possible to write all this into a function? Okay, so I'll write this inside a function, and is it possible to try in main, throw in function, and catch again in main? The answer is yes. So let me again repeat. I want to try everything inside a function and throw inside the function, but catch inside main now. Okay, so what I'll do is I'll keep only if b is equal to 0, and other things I'll remove because I'm going to functions now. I think I didn't save that. Let me save this as program 2. New save. Save this as okay. Now what? B is 0. Okay, this things I'm removing. Now let me write int let us say do division of two variables which are formals x and y. This is my function prototype, which is int do division of two variables. Okay, so a and b are entered, but now this part of the code I want to write here. Instead of writing C out, I'll return C is equal to. So what I'll do is I'll try C is equal to do div of a comma b. So here I will return. No, it is not C. Let me take Z here. Let us take Z here, and then X and then Y. Here it is Y. Here it is X divided by Z. X divided by Y here. I need to declare clear. So what we are doing is we are handling y inside the function. I mean, we are throwing inside the function. So it is possible to separate the sources of exceptions as a function, and you can again revert the control back to a specific exception handler. So notice that you are sending a string here. This is char star. So this is caught here, and the corresponding message will be printed. And int e and then universal exception handler, all these things will not be printed, and then you will get have a good day. Okay, so let us run. Now if I enter 5 and then 0, I get divided by 0. That means it is possible to separate inside the functions. It is possible to throw. Am I clear? Am I clear? Maybe
Sir, can we keep try also in function?
can we keep?
Also in function, sir.
I didn't hear properly.
Can we keep try? Can we keep try also in function, sir? Try.
No. You cannot keep try inside function. Try has to be in main. Try and catch must be within the same vicinity. Try and catch must be within the same vicinity.
Okay, sir.
Next. Another point is, if an exception is thrown and it is not caught anywhere, then the program will terminate abnormally. This we have already seen. For example, you are throwing 1, then you are catching integer. But if you are throwing 0, which is an ASCII, then the program will terminate abruptly. This is point number 4. Okay? This we have already seen. Yes or no? Yes or no?
Yes, sir.
Okay. Next, now a little deeper. It is possible to throw the objects from try block to the catch block. Just remember this slide. No need to code and understand. It is possible to throw the objects from try block. So assume that there is a base class. Assume that there is a derived class. When you are creating a object of a derived class, okay, so when you throw the derived class object as an exception handler based object, then if the base class exception is handled before the derived class, then the derived class exception will never be executed. So if you have written a base class exception handler, even though if you are throwing a derived class object, then your base class exception handler will be caught. Now in the code which is there on the right hand side of your code, you will get caught base exception. Okay. But however, this is a bad programming. So because what are you throwing is a derived class object, so it is better to handle the derived class object exception. So instead, therefore, the remedy is you handle the derived class exceptions first, because what you are throwing is a derived class object. So you move this catch, which is a derived D, above B, above base class catch object handler. Okay.
Sir, can we use virtual here also?
Yeah. I'll come here. It's possible. It is possible to use virtual where in the see, virtual you talk in terms of inheritance, not in terms of catches. Okay. So
Okay, sir.
there is a Any other doubts? Virtual we use in two cases. One is virtual can be a virtual function uh, when you use what, dynamic polymorphism, and second is when you use the diamond problem, virtual base class. So that concept will be retained, but whenever you are throwing a derived class object as an exception handler policy, then you always write a catch of derived object first. Then you handle the base class object. Okay. Next, moving on, there is a specific exception class. Okay, so there is a class which is implemented in C98 compiler, C++ 98 compiler. So inside this exception class, there is a class named by exception. There are public member functions. One is a constructor exception with the same name as that of exception. This is the constructor by using which we are in a position to throw the primitive data types, which is in line number 3. Then there is a copy constructor, exception, constant exception ampersand throw. Then there is a assignment operator overloaded exception class with the throw. And there is a virtual destructor. And there is a seventh specific member function which is used in order to define your own exceptions. Okay. So these details are not necessary. They are not there in the syllabus. For the sake of completeness, I'm just projecting as of now. Okay. So there is a class which is by name exception. And in C++, there are different types of standard exceptions. So once you use hash include exception.h, once you use hash include exception.h, then it is possible to bring in all those standard exceptions into your design. So that is the standard exception classes, which is there on your slide, your screens. So you have a exception class, base class. Then there are 4 different standard types of derived classes that will handle the exceptions. One is bad allocation, second is logical error, third is runtime error, and fourth is bad casting. These are the 4 types of standard exceptions. Are you following? Are you listening?
Yes, sir.
Yeah, so there is an exception class. This exception class is a base class. Under this, there will be 4 derived classes to handle these standard exceptions. Okay, one is bad allocation, second is bad casting. Then it doesn't have further childs. Whereas logical error and runtime errors will have further childs. In logic error, you have length error, domain error, out of range error, invalid arguments. In runtime error, you have range error, overflow error, or underflow error. Now, as a part of the exception framework which is supported in C++, every student needs to remember these standard exceptions, and you have to replicate this diagram whenever the exceptions were asked in the external examination questions, along with 1 or 2 examples, what we have discussed. Okay. Is it clear? Is it clear? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Two more points. With that, we will be completing the exceptions. So it is also possible to write partly catch and partly some other catch. Okay. In try catch block, it can be nested. Also, an exception can be rethrown by using throw. See here, there is a try. Inside try, there is a throw. Okay, so there is a throw of 20. So inside this nested try, there is a integer catch. So there, this exception has been handled partly or partially, and again it has been thrown. Now notice that there is no more argument which is required here because of integer only you got here. So again the remaining exception can be handled in the outer throw. So the point is, it is possible to have nested try blocks with many throws, and it is also possible to limit part of the code in a specific catch block, retaining the other part of the code in some other catch block. Okay, so if you have two catches with the two integers, in which the try vicinity is important. And also notice that you cannot write two exception handlers with the same arguments type within the same scope. Okay. This is also sort of observation, not necessary, but better to know. Better to know, because there could be instances of 2 marks questions with this as predicted code. I mean, some logic with this can be given. You will be asked to predict the output.
Sir,
Here,
if nested catch has a throw of char,
if nested catch has throw
throw of char, where it will go?
no, if nested catch will have a throw of char, then you are deviating the exception handler the definition. You are catching an integer, you have handled the integer, and then because you are throwing a character again, then it comes to a character catch only. It comes to a character catch. You can test it.
Sir, is that nested catch or catch of outside try?
If the nested catch is catch of outside try, yeah, that these are different permutations. You have to start working, then only you will understand. For all the possibilities, the program flow will definitely execute. One integer, one char, and then one char, one integer, both integers. But both integers within the vicinity is not allowed. Within the same scope is not allowed. Okay? Clear? Writing
Sir,
writing same catcher.
I mean,
Yeah. Please.
sir, this nested catch has throw of char. That will go to throw of nested catch or outside catch.
Throw of nested catch, it will not go, because you are okay, you are talking about nested catcher. If it is throwing, that means you are still in first try block, right? Okay, so it will go to the catch block of char. It will go. Okay. Can somebody come in? Am I audible? Is it okay? Have you understood?
Yes, sir.
Yes, sir.
Yeah, and then there are two more points. Now notice that when an exception is thrown, all objects which are created inside the enclosing of try block will be destructed before the control is transferred back to the catch. See, in main, if you start executing this program, in main, in try, you have created a test T1. So T1 will call its default constructor, that is constructor of test. Now if it is throwing an integer 10, before it goes to catch, it calls the destructor and then it goes. The point is all objects which are created inside the enclosing try block are destructed before the control is transferred to catch block. So before it goes to catch block, since you have already created, you called a constructor, it initially calls the destructor and then it goes to catch block. Okay. Now this we have already discussed. I think you understood. Did you understood the point here? If you are throwing a, sorry, if you are creating an object inside the try block, you are handling an exception, and if you got an exception, before it goes to the exception handler, it calls the destructor. Am I clear?
Sir, can you explain once again?
Okay. Maybe I'll take an example. You want me to take an example code? Same thing. You can start.
Yes, sir.
Okay. Is a function. So assume that there is a class. So let us say there is a class. The class name is A. Okay. Now you have private, and you have public. You have a constructor. As a part of constructor, just saying that this is your A's constructor, and as a part of destructor, I'll say that cout is destructor of A's constructor, and then A's destructor. There are no data elements, but let me take one data element, which is okay. Right. So what I'll do is in main, A1 is an object, but this A1 I'm writing in try block. If you write this in try block, then if you throw, let us say, a number 1, okay, then it is catch. You have to handle an exception E. Okay, so then I'll say that cout, I got an exception. Okay. So I'm intentionally throwing an exception without taking any input. There is no input here. So the point here is, first the constructor of A is called, then the then the destructor of A is called, and then the exception handler is called. First you will get AC, then you will get AD, then you will get I got an exception. So maybe I'll write a backslash in here. Okay, so let me execute this. You will get constructor of A, you will get destructor of A, then you will get the exception. But unlike in earlier programs, your program will be completed and then only after get ch you use it to get the destructor, right? But in exception,
Sir,
yes,
CER, no, sir.
ER. Yeah, you can also write that. So, let me rerun this. Okay. ACAD, constructor and then destructor, and then you will get the exception. Okay. Am I clear? Whenever you deal with exceptions, am I clear? Can somebody acknowledge?
Yes, sir.
Okay. This we have already discussed. Exceptions can be thrown from functions with a try ahead of block. Okay. And then this is beyond the scope. It is also possible to write custom specific exception handler You can define your own exceptions. Somebody is interested to see the syntax. There is a function by name what of. Okay, so you have to define a structure type, which is a my exception, and uses the syntax of a derived class, which is publicly inherited from the exception class. And you have to also include exception, which is in line number 2. Then this is the type of defining your own exception. Your exception type is my exception. Okay, so that my exception can be thrown in main. Need not necessary to remember this. But now let me conclude by saying that if you are asked to explain about exceptions, you need to discuss about the definition of an exception first. Are you listening? Are you listening?
Yes, sir.
You have to
Yes, sir.
discuss. Yeah, you have to discuss, or you have to write what do you mean by an exception. You have to discuss about the syntax of try, throw, and catch block. Okay, and then you have to discuss with 1 or 2 examples. Preferably, I suggest you use the divided by 0 with a function example. And you mention the universal catcher. You mention the universal catcher, which is catch triple dot. Mention the significance. Mention the significance. That is more than enough. That is there in the syllabus. Handling the exceptions in inheritance is not there in the syllabus. However, for the sake of completeness, I have included that. Okay. Right. And the last part is you need to specify what are the standard exceptions. This diagram. So all this you have to write if it is for long answer questions. Clear? Am I clear?
Yes, sir.
Yeah. So let me again repeat what has to be written. You have to define an exception. You have to discuss the syntax. You have to write one example, preferably with the divided by 0 with function. You have to write universal catcher. You have to write the universal catcher, which is catch triple dot. Okay. And finally, you have to specify that there are standard exceptions, which are of 4 type, which are possible by keeping hash include exception.h. Don't keep std exception. You keep hash include exception.h. Okay. And those 4 standard exception types needs to be written along with this diagram. This diagram is compulsory for the long answer questions. All other aspects what I have discussed, it could be asked for 2 marks for predicting the output of any code segment. Okay. So with this, I am officially concluding that our syllabus is almost completed. Are you listening? Are you listening?
Yes, sir.
Yeah, so with this, I am officially concluding that our syllabus is almost concluded. We are having some small, small topics such as namespaces, then using, then constant pointer and pointer to a constant. So those things we will discuss in the upcoming classes parallelly along with your assessment. Okay, so starting from Monday, I actually asked you to, I told you that your assessment will start, but I think we can start from tomorrow itself. Is that okay? Please come in. Is that okay?
Monday, sir.
Monday. Okay, fine. It's up to you. Take your own time. Okay, let me stop here, and I request all of you to please focus on exceptions, because whatever I have asked to write, only that part, if you remember, it is as if like always you'll get 5 marks always as granted. Okay, so try, throw, and catch. One of the commonly done mistakes by the student is writing after a try block, writing something like condition. Try some condition. That is wrong. Try has to be empty. Okay, and catch has to be with a function like. Writing a return type inside before catch is also a serious error. It is not a function. It is a flow of control. It is a handler. Okay, so with this, let me stop here and let me sign out. And then if you have any other doubts, we will take up in the next class. Everybody are leaving. Living very fast. 71, you are there? She is not there. Okay. Akshaya, you are 123?
Yes, sir, I'm here.
Yeah.
Yes, sir.
So any problems from your class as far as C++ is concerned?
No, sir.
Everybody are in a position and are you comfortable in understanding the concepts and executing?
Yes, sir.
Okay. If there are any
Sir?
issues, yeah.
Sir, is there any possibility that next week we'll write?
Next week what? Regards, sir?
Not record, sir. Internal.
No, no.
Lab internal.
No. What is there? Two programs you have to start writing. No? What is there? No, only when we say that you have exams, then only students will start studying. So that is the reason why I said no. You write it on Monday only.
Okay, sir.
I think it is next week only for you. When do you have your next class? On Wednesday after.
Sir.
On Wednesday afternoon only, right?
Yes, sir. Yes.
Okay, but I think yesterday I said it will be from Monday onwards, right?
Yes, sir.
So fine, I'll prepare the timeline and I'll start assessment from Monday onwards.
Okay, sir.
Okay.
Okay, sir.
If there is something that you want me to execute, like some of the students wants to execute some concepts wherein they don't have laptops, probably I can initiate another session. Whatever concepts you want me to repeat, are the students are willing to repeat, I can repeat those.
Okay, sir.
But to my knowledge, I think the recorded sessions of ours will be of good use.
Yes, sir.
Okay, so if still students are finding difficulties, please ask them to get back to me without any hesitation.
Sure, sir.
Okay. Okay, then I'm signing out and we'll meet tomorrow then.